New on Curiosity Stream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is Spacetime, Series 24, Episode 26. Coming up on Spacetime, astronomers believe they may have discovered a neutron star at the heart of supernova 1987A, the mystery of the Martian moons, and China launches 3 more spy satellites. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers believe they may have confirmed the existence of a neutron star produced by supernova 1987A. As the first nearby supernova since the invention of the telescope, and the first to be visible with the unaided eye in 400 years, supernova 1987A sparked great excitement amongst astronomers, quickly becoming one of the most studied objects in the sky. The supernova erupted on February the 24th, 1987 in the Large Magellanic Cloud, a small companion galaxy to our own Milky Way galaxy about 170,000 light-years away. While astronomers watched debris explode outwards from the site of the detonation, they were also looking for what could have remained from the star's core, a neutron star or possibly stellar mass black hole. The study's lead author, Emmanuel Greco from the University of Paloma, says that for the past 34 years, astronomers have been sifting through the stellar debris of 1987A in search for the neutron star they expect to be there. There have been lots of hints, but they've all turned out to be dead ends, leading to speculation that maybe the progenitor collapsed beyond the neutron star stage and formed a black hole. But Greco and colleagues believe their latest results may finally have solved the puzzle. When a star explodes in a Type II or core collapse supernova explosion, it collapses down in on itself before the outer layers are blasted into space. All this mass compressing down onto the core turns it into one of the densest objects in the known universe, a neutron star. Imagine a mass greater than our Sun squeezed into an area no bigger than a city. These objects are called neutron stars because the protons and electrons in their atoms have been crushed together so tightly by their own gravity that they turn into neutrons. Rapidly rotating and highly magnetized neutron stars called pulsars produce a lighthouse-like beam of radiation that astronomers detect as pulses when its rotation sweeps the beam across the sky and in line of sight of the Earth. And there's a subset of pulsars that produce powerful winds from their surfaces, sometimes travelling at near the speed of light. And these create intricate structures of charged particles and magnetic fields known as pulsar wind nebulae. Greco and colleagues used observations from NASA's Chandra X-ray Observatory, together with NASA's Nuclear Spectroscopic Telescope Array NuSTAR, to detect relatively low-energy X-rays from supernova 1987A's debris crashing into surrounding material. They also found evidence of high-energy particles, using NuSTAR's ability to detect more energetic X-rays. The authors then combined their data with observations from ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile, to produce an intriguing collection of evidence which supports the presence of a neutron star at the centre of supernova 1987A. There are 2 likely explanations for this energetic X-ray emission. It's either a pulsar wind nebula, meaning a neutron star at the centre, or its particles being accelerated to high energies by the blast wave of the explosion. The latter effect doesn't require the presence of a pulsar, and it occurs over much larger distances from the centre of the explosion. But by arguing against the scenario of a blast wave acceleration, the evidence points to the idea of a pulsar wind nebula, and that means a neutron star must be there. See, first, the brightness of the higher energy X-rays remained about the same between 2012 and 2014, while the radio emissions, which were detected with the Australia Telescope Compact Array, increased. Now that goes against the expectations for a blast wave scenario. Now also, the authors have estimated it would take almost 400 years to accelerate the electrons up to the highest energy seen in the new star data. And of course the problem there is that's well over 10 times older than the age of the remnant. The Chandra and New Star data also supported a 2020 result from ALMA, which provided possible evidence for the structure of a pulsar wind nebula in the millimetre wavelength band. Of course, if indeed this is a pulsar at the centre of supernova 1987A, it would be the youngest one ever found. The centre of supernova 1987A is surrounded by gas and dust. So the authors used state-of-the-art simulations to understand how this material would absorb X-rays at different energies. And that enabled a more accurate interpretation of the X-ray spectrum, in other words, the amount of X-rays at different energies. And this then enabled the authors to estimate what the spectrum of the central regions of 1987A would be like without the obscuring material. The stellar debris around the suspected pulsar plays an important role by heavily absorbing its lower energy X-ray emissions, making it undetectable at the present time. But the model predicts that this material should disperse over the next few years, which will consequently reduce its absorbing power. Thus, the pulsar emission is expected to finally emerge in about 10 years' time, revealing the existence of the neutron star. This is Space Time. Still to come, the mystery of the Martian moons. And China launches 3 more spy satellites. All that and much more still to come on Space Time.
New on CuriosityStream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at CuriosityStream.com.
A new study claims the 2 Martian moons Phobos and Deimos were likely created through a titanic collision in orbit around the red planet more than 1 billion years ago. The findings, reported in the journal Nature Astronomy, are based on extensive computer simulations. Phobos and Deimos have fascinated astronomers ever since their discovery in 1877. Both are tiny. Phobos has a diameter of just 22 kilometres, 160 times smaller than the Earth's moon, and Deimos is even smaller again, with a diameter of just 12 kilometres. And unlike the spherical shape of Earth's moon, the 2 Martian moons are both irregular potato-shaped, like asteroids. And that's led to ongoing debate about their origins. Some astronomers suggest they're captured asteroids or meteoroids, while others point out their almost circular orbits around Mars' equatorial plane suggest that they must have formed around the red planet. You see, captured asteroids would have more eccentric orbits in random inclinations. When scientists looked at their computer simulations and played the tape backwards, it showed the 2 moons' orbits intersecting between 1 and 2.7 billion years ago. The exact time depends on the composition and physical properties of the 2 moons. What it suggests is that Mars once had a larger celestial body orbiting it, and this was impacted by another object, with enough force to cause both bodies to smash apart, eventually coalescing into Phobos and Deimos as they are today. The authors reached their conclusions by determining the gravitational tidal interactions between the 2 moons and Mars. The dissipation of these forces depends on the mass and distance between them. Observations suggest that both Phobos and Deimos are extremely porous, with densities of less than 2 grams per cubic centimetre. Now that's much lower than the average density of, say, the Earth, which is around 5.5 grams per cubic centimetre. Phobos also appears to contain lots of internal cavities. These might contain water ice, which is helping to dissipate a significant amount of tidal energy. A more detailed analysis will have to wait until Japan launches its Martian Moon's Exploration Sample Return mission that'll fly to land on Phobos in 2025 and also do a flyby of Deimos. The computer simulations suggested the progenitor to Phobos and Deimos was orbiting Mars at a similar distance to the 30.3-hour, 23,460 km high orbit of Deimos today, and that Deimos is slowly receding from the red planet. Now, by contrast, Phobos' 7-hour 39-minute, 6,000 km high orbit above Mars is degrading at a rate of about 2 centimeters per Earth year. And this suggests that Phobos will pass beyond its Roche limit and be torn apart by Mars's gravitational tidal forces in around 30 to 50 million years' time, most likely forming a spectacular debris ring around the red planet. This is Space Time. Still to come, China launches 3 more spy satellites. And later in the science report, a giant iceberg larger than a small country breaks off from Antarctica's Brunt ice shelf. All that and much more still to come on Space Time. China has launched another 3 of what Beijing euphemistically referred to as remote sensing satellites. The 3 spacecraft were flown aboard a Long March 4C rocket from the Jiuquan Satellite Launch Center in northwestern China's Gobi Desert. The Chinese government claimed the 2,700-kilogram spacecraft will be used for electromagnetic environmental surveys and other related technology tests. However, their orbits confirm that in reality, these are People's Liberation Army Yaogan 31 surveillance and intelligence gathering reconnaissance satellites. They've been placed into 1,100-kilometre high orbits inclined at 63 degrees, which conveniently takes them over key military facilities of several nations of interest to Beijing. The spacecraft are designed to carry optical wavelength cameras, synthetic aperture radars, and electronic intelligence gathering payloads to monitor specific targets. It's the 3rd group of this new updated Yaogan 31 type spy satellite to be launched by Beijing. The first group was launched in April 2018 and a second group of 3 in January this year. And in case you're keeping count, this brings to 73 the total number of Yaogan spy satellites launched by Beijing since the Yaogan 1 first blasted off from the Taiyuan Satellite Launch Center in northern China's Jiangxi province way back in April 2006. And during that time, there's only been 1 launch failure. That was in May 2019. Intelligence sources suggest China are planning to launch at least another 57 Yaogan spy satellites. China's growing constellation of these satellites allows them to monitor vast areas of the planet with reduced time between passes, the aim being to provide close to continuous coverage over wide areas of interest. Meanwhile, China's private space industry is continuing to grow with a successful suborbital launch of a prototype sounding rocket. OneSpace have undertaken the maiden test launch of its 9.4-metre-long OSX-6B rocket, carrying a test payload over some 300 kilometres. The mission, which lasted around 580 seconds, flew from a mobile launcher and tested a range of key technologies. However, it's not been all good news for China's growing private space industry. Another company, iSpace, have failed to achieve orbit with its new Hyperbola 1 4-stage solid-fueled rocket. The Hyperbola 1 is based on the People's Liberation Army DF-15 missile. The mission was attempting to launch the Arctic CubeSat into orbit from the Jiuquan Satellite Launch Center in the Gobi Desert region of Inner Mongolia. Reports suggest problems began in the seconds following liftoff, with destruction occurring shortly after Max Q, the period of maximum dynamic pressure on the spacecraft. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists have developed a new modular protein biosensor that can rapidly detect COVID-19 virus proteins and antibodies. A report in the journal Nature claims the new research focuses on a class of protein switches in which the binding of the peptide key triggers biological outputs. The underlying technology could be as revolutionary as CRISPR gene editing or protein folding keys, giving scientists the ability to control living cells using designer proteins. Proteins do different jobs in living organisms depending on their composition and the environment they're in. and protein switches are proteins that can change their configuration in response to a biological stimulus, altering function. The researchers engineered these new modular protein switches to become bioluminescent, in other words, to glow in the presence of the COVID-19 virus protein or its antibodies. But the thing is, and this is where the magic comes in, they could have been designed to react to whatever scientists want. You see, this new research streamlines the process of using modular design, allowing protein switches to be used to test blood samples for, say, breast cancer proteins, hepatitis virus proteins, lymphoma proteins, or bacterial toxins. And as well as diagnostic applications, these switches could also be used to deliver therapeutic drugs to kill, say, cancer cells, or to initiate changes at a molecular level, thereby unlocking precise control of living cells and ultimately human health. A giant iceberg the size of a small country has broken off from the northern section of Antarctica's Brunt ice shelf. New radar images by the European Space Agency's Sentinel-1 satellite show the 1,270 square kilometre iceberg breaking free and moving rapidly away from the floating ice shelf. Glaciologists have been closely monitoring numerous cracks and chasms that have slowly been forming in the 150-metre thick Brunt ice shelf over the past few years. Then in late 2019, a new crack was spotted in the portion of the ice shelf north of the McDonald ice rumples, heading towards another large crack near the Stancomb-Wills glacier tongue and expanding at around 5 metres a day. Then in the early hours of Friday morning, the newer crack widened rapidly and the ice sheet finally broke free from the rest of the ice shelf. The first of Australia's new Loyal Wingman autonomous unmanned aircraft prototypes has undertaken a successful maiden test flight at the Woomera Rocket Range in outback South Australia. The new drone, which was designed, engineered and manufactured in Australia, is one of 3 prototypes built at Boeing's automated production facility in Brisbane as proof of concept for full-scale production. The 12-metre-long aircraft have 8-metre wingspans and are designed to use a range of different mission-specific exchangeable nose cone pods. They'll provide additional defence, intelligence gathering, surveillance and reconnaissance capabilities, acting as scouts, and can be programmed to use artificial intelligence to respond to new information on the battlefield or for challenging enemy fire if attacked. The UAVs have a range of over 3,700 kilometres and will act as a force multiplier, supporting manned jet fighters such as the F-35 Lightning Joint Strike Fighter, FA-18EF Super Hornets and EA-18G Growlers, as well as frontline support aircraft such as KC-30A aerial refuelers and E-7A Wedgetail AWAC airborne early warning and control aircraft. The new unmanned jets will join the ADF's growing inventory of UAV drones, which will include the new Global Hawk-based MQ-4C Tritons, which will work with P-8 Poseidon maritime surveillance aircraft, and MQ-9B Sky Guardian Predator B attack and reconnaissance drones. Well, you might be surprised to find out that with Australia housing some of the most venomous spiders, snakes and jellyfish in the world, the winner for the most hospitalisations due to a venomous bite or sting is actually the humble bee. A report by the Australian Institute of Health and Welfare found that between 2017 and 2018, there were over 3,500 Aussies in hospital due to contact with a venomous animal or plant. And the authors found that more than a quarter of these were due to bee or wasp stings. The study found allergic reactions were the most common reason why a buzzy buddy caused the trip to the emergency department, ending in 12 of the 19 deaths recorded during that period. By comparison, spider bites accounted for 19% of emergency visits to hospital, with snakes coming in third at 17%. Our first look at the new MacBook Air with M1 processor, rumours of a foldable iPhone on the way, and better password protection for Android. With all the details on these and more, we're joined by Alex Zaharov-Reutt from ITY.com.
This is the new MacBook Air with the M1 processor, which is based on a supercharged iPhone/iPad style processor, except that it is designed to be even more powerful and run all of the apps that run on a Mac. But importantly, it uses something called Rosetta 2, a translation software, to run any app that runs on the Intel processor and actually runs it better than Intel processors can run it, which is quite funny and bad news for Intel, great news for Apple. So this machine, I've only had it for 72 hours as we're talking, but I've loaded all the different programs I use onto it. it's fast. The battery life seems to be like triple what I was getting on the Intel device. And, when I use Word 365 from the very latest Office 365, so when I do certain things, I see that little spinning beach ball of death, which I realize is the Intel spinning beach ball of death, not the Apple one, because on the MacBook Pro, I don't see that. Everything just pops into life. So it's really incredible with incredible battery life. If you've got an Intel-based Mac, it's really going to be time to upgrade.
And not only is there a new M1 Mac, there's also rumors of a foldable iPhone.
Yeah, well, this probably would be based around a future iPhone 13 or 14. We have seen the initial foldable phones from people like Samsung with the unfortunate crease down the middle. We've also seen foldable phones from Huawei, which fold the other way around. We've also seen scrollable phones or prototypes from both TCL and LG, where the phone looks like a normal-sized phone, but just magically expands outwards to create an iPad mini-style device. And the rumors are out there saying that Apple is going to have this foldable phone. It'll have stylus compatibility with Apple Pencil, and that some reports are saying, well, Apple will get rid of the iPad mini. But I don't see that happening anytime soon. These devices aren't expected to arrive until next year at the very earliest, and probably 2023. Because, Apple's never the first at launching anything. Generally speaking, they are the last.
And last but by no means least, Google are offering features on Androids to check for compromised passwords.
Yeah, I've seen this on Safari, for example, on my Mac, but on your Android device, if you've got Android 9 or up, there'll be an update that will type a password into the Chrome browser. It will tell you, it will say, hey, that password's too weak. Or we've seen that password before on password dumps from sites that were hacked. And this is important because, there are still people out there using things like 1, 2, 3, 4, 5, 6 or password or WordPass or, very, very simple stuff. I love you, stuff like that as the password. See these lists of passwords being released every year, and they always list the top, 20 or 30 or top 100. And they're very simple words, very, very easy to guess, very easy to hack and crack, very easy for people to try by these brute force attacks. And it's very important to use some sort of password manager. I use 1Password, but there's several out there. But it's good to see that, the phone maker, or in this case, Google, is putting it directly into Android itself to warn you that, hey, your password is just not safe. And, if you then think, well, I'll double, at least I'll use what I normally use, but double it, for example, and put some exclamation marks or do something to get more complicated, but hopefully easy enough for you to remember if you insist on not using a password manager. Thing that this is coming to Android devices. There are more than 2 billion Androids out there, and new ones sold all the time. So this will become a standard feature that we'll see replicated everywhere.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.